Okay, let's do another example here. Let's say we have an object that's 4 kilograms moving at 3 meters per second to the right, and we've got a spring over here uh, that the spring constant K is 9 newtons per meter. In other words, simply conceptually, what that means is if you squeeze this spring by 1 meter, it'll be at that point exerting a force of 9. How come that's not a constant force? Every compression before 1 meter is less than 9 newtons. Every compression greater than 1 meter is more than 9 newtons. So this just gives us a ratio. K is simply the ratio between how much force a spring will exert per meter that you stretch it or compress it. So the question is, how much does the spring get compressed? So what we want to do here is use the fact that the work done by the spring right here is going to be the change in kinetic energy. And when you're asking how much does the spring get compressed, you could ask the same question is, how much does it get compressed until this object does what? Well, it will no longer compress the spring once it stops. So that's when it stops getting compressed, is when this has no kinetic energy. In other words, the work done by the spring will be the change in kinetic energy. Now I want you to think about this. This is moving at 3 meters per second. The force is to the left. Is the change in kinetic energy going to be positive or negative? If you're slowing something down, no matter which direction it's going, it has a negative change in kinetic energy. In other words, it is losing kinetic energy. So to figure this out, all I'm going to do is figure out the work done by the spring, and that's going to be the change in kinetic energy. This is the final kinetic energy minus initial kinetic energy. Notice any change is always final minus initial. And how do I know this is 0? Well, because what in this is going to be 0 when the object stops moving? The velocity will be 0. That's how I got that. So I get the work done by the spring is -1/2 mv initial squared. And that is going to give me this. So I'm substituting for the work done by the spring -1/2 kx squared. Why negative? How do I know that this work done by the spring is going to be negative? You got to look at your diagram, figure out what's going on. We know that the force, while the spring's being compressed, the force of the spring is going to be this way. That's the force of the spring. The displacement is going to be to the right. This displacement is to the right. The angle between those two vectors is 180 degrees. It's going to be slowing the object down. It's going to be losing kinetic energy. So this is the work done by the spring. Therefore, we know is negative, and in fact, it's -1/2 kx squared. You have to decide for yourself, is the work done by the spring going to be positive or negative? Because work done by the spring could be either. So what I end up with is 1/2 kx squared, work done by the spring. That's going to equal what I have left over here, which is simply 1/2, which is 1/2 -1/2 mv initial squared. What am I trying to find? I want to figure out this x right here. This x is what I want. So I just solve symbolically for x, and notice that I did solve this whole thing symbolically before I plugged in any numbers. Just solve for x, plug in your numbers, and you will see that the spring will compress 2 meters.